to the next point, which is the displacement and velocity and acceleration of SHM. As you've already understood that the displacement equation of SHM, of a body in SHM, is represented by xt is equals to a cos omega t plus phi, and the a is the maximum displacement, omega is the angular frequency, and omega t plus phi is the phase. Phi is the phase constant. You can also write here phi is the phase constant. Actually, in UCM, the body moves on a circular path, and the projection of circular path on x-axis or on y-axis is represented by sine and cosine functions. Moreover, the higher studies, you will see that a body in SHM, the basic general equation that force is directly proportional to negative of displacement. If you will solve these equations, you will get answer in sine or cosine functions. So from there I can say that a body which is moving xt, the displacement is represented in terms of sine function than it is in SHM. Okay, so SHM displacement equation is given by this. Dear students, if I differentiate this equation, I will get velocity, and further differentiation of it will give the acceleration. So here you can see velocity and acceleration in SHM. The differentiation of the displacement, see the displacement is a cos omega t plus phi. What if you differentiate it? A will remain as it is. Cos differentiation is minus sine, okay, minus sine as it is, and cos omega t is there, and omega t differentiation is omega, so omega also comes out. Sine omega t plus phi maximum value, actually it varies from 0 to 1, so its maximum value is 1, so we can say the maximum velocity is omega a, which is at the mean position, because you know here when the body is passing through mean position, it goes with maximum velocity. For example, a simple pendulum. Acceleration, how to find out? See, acceleration is the differentiation of velocity. So if you differentiate this above equation, this equation, if I differentiate this equation, then omega is t is to be differentiated, so omega square comes out. A is as it is, so a is as it is, and here you can see here, as you can see, this omega is minus sine, cos is differentiation is, sorry, this sine differentiation is plus cos, so here you get cos. Okay, a cos omega t is again the formula of displacement, so I can write here the expression after differentiation as at is equals to minus omega square xt, as you can see here. Again, the maximum value of a is omega square into a at extreme positions, right? I hope it is clear to you. The next topic comes force law for SHM. Dear students, if a body is in SHM, then force acting on it is by Newton's second law, F is equals to ma, and if I put the value of a, I got minus omega square a, okay, maximum, and at any arbitrary position or time, the value is minus omega square x t, which is a function of time. M omega square, if I treat it as constant, then I can say f is directly proportional to, or f is equals to minus kx, okay, where k is m omega square. I write it as force constant, so it shows that this equation clears that force is directly proportional to negative of displacement, so it is in SHM. So the body is in SHM. Okay, it is the basic fundamental definition of SHM. And moreover, if you compare with this spring constant k, stiffness, then you know by Hooke's law f is equals to minus kx. Dear student, this k is mean for any constant which is arriving while deriving this force law for spring, but this constant k is for stiffness of the spring. If we compare both of these two, we find that here minus m omega square into x. If we compare, then we can say the spring constant k is equals to m omega square, or we can say omega is equals to root k by m. I hope it is clear. One more thing is that to find out the time period, you already know t is equals to 2 pi upon omega. If you put the value, t comes out to be t is equals to 2 pi root k upon m. So this is one question. If you are having one block of mass m connected with the spring, and if you are moving this block here, then the force that comes out is minus kx. Okay, and if you compare with the force of SHM, then it is omega comes out to be k upon m, and t is time period of oscillation. Time is equals to distance 2 pi, one complete distance, upon speed omega, angular speed, then omega value is root k upon m. So t is equals to 2 pi root, sorry, here it will come out to be m upon k, because you write omega is equals to k upon m. So t comes out to be t is equals to 2 pi root m upon k. I hope this point is very clear to you.